about halfway through, and then we'll take a break, and I'll play a video for you guys. And then after the video, we'll get back on. So IFR Enroute Charts, and this is what we were going through last night, was these IFR Enroute Charts. So when we talk about IFR Enroute Charts, we're talking about those high and low charts. We use RNav, which is just GPS-based navigation. We'll talk about the T and the Q routes. Oops, sorry, my mouse is really touchy. And then we'll also talk about IFR preferred routes. We'll talk about these tower en route control routes. And then the North American route system, extended operations, or ETOPS. We'll just kind of briefly talk about that. Low and high altitude chart information, and then area charts. So here you can see, and we kind of talked about yesterday, we have the low altitude charts, and as you can see, there's a lot more low altitude charts than there are high charts. Now we have more high charts than this now. This screenshot was taken from a while ago. But yeah, the difference between the two charts is, like we said before, low altitude charts are for below flight level 180 or 18,000 feet. And the primary way of navigating on these low altitude charts is going to be what we call Victor Airways. And, if you can remember, those are those little highways that I pointed out yesterday. The high altitude charts are for everything above flight level 180 or 18,000 feet. Up to and including flight level 450 is typically where we're gonna, really nothing that is civilian operates above flight level 450. And the primary route that we're going to use on those charts is going to be jet routes. That's what we're going to call those. So IFR routes, there are Federal Airways. So this is the Victor Airways and the jet routes. So like Rex was saying yesterday, they do have a width. So it's kind of like flying through boxes in the sky, you could say. And that width is 4 nautical miles wide. And for the Victor Airways, the floor of those routes are at 1,200 feet above ground level. So that's kind of where those Victor Airways start. They use magnetic course. So if you look at this course here, or right here, you can see that it has this degree or radial that you're going to fly. It's the 270 radial off of here, or the 090 radial. Those are being shown as magnetic course. Now we're going to talk about magnetic course a little bit more here. But basically there's a magnetic compass in the aircraft, and that's what we use for magnetic course, is that magnetic compass. So magnetic course and true north, or magnetic north and true north are actually in different locations. And we'll kind of touch base with that. But NA, there's prohibited areas that you cannot fly on some of these routes. And these routes kind of guide you through the unauthorized areas that we don't want you flying through. And Victor Airways, so up to 18,000 feet, we'll be flying a Victor Airway. And did I go over my NEOD sweeping with you guys? I'm pretty sure I did when we were going through the FARs. But
you did in the very beginning.
Yeah, so this just kind of is the same thing. Actually, well, Victor Airways are a little bit different. North and south. So if we're flying north-south, odd altitudes, east-west, even altitudes. Jet routes, it changes. So anything that we're going to be planning with is going to be the NEOD sweeping. So where we talk about, like, you can see this compass rose right here. Everything from 360 or 0 degrees down to 179. So north to the east will be even. Odd. Sorry, NEOD. So that will be odd. And then 180 back to 359, almost due north, will be even altitudes that we fly. So then on these routes, something that you will see is this little crooked line here. This is what we call a changeover point. So these VORs, we talked about how they're broadcasting a signal and telling us where we are in reference to these two different stations. Well, the signal, if we see one of these changeover points, you can see this one says 45 and this one says 22. That means that this signal, because of terrain, will only be accurate up to 22 miles from this station. And at this 22 miles from this station, or 45 miles from this station, that's where we're going. That's where the pilot's going to change over from using this navigational aid to this navigational aid. Does that make sense? So he can only, he has two different navigational radios, but he's only going to be navigating off of one of those radios. And so once he hits this point, the 45 miles from this station, he'll just switch over to this station, and that'll be 22 miles from this station. So that's all that changes.
So they're just different frequencies, kind of basically he just switches over when he hits that point to the other station's frequency, or?
Exactly.
Okay.
It's actually a VHF, so a VHF radio. So VHF stands for very high frequency. And the VOR, if you remember what VOR stands for, VOR stands for very high frequency, or VHF, omnidirectional radar. And so it's broadcasting, when it says that VHF, it's broadcasting on the VHF band. And so just like with your car radio, he actually tunes in the airplane's radio to these different stations. So
something that I noticed with the north, south, east, and west, it's identical to the highways we have here on the ground. Your I-15 and I-70, the numbers are odd and even on the ground as well.
Oh, so yeah.
That's kind of the way that I remember it.
Yeah, that's a good point.
So that's, if you're aware of that, you can be aware of that in the air. So that's one way that I can remember that myself anyway.
Yeah, that's a good point. I actually didn't know that. So
Yeah, all your freeways, if they're east and west, they're all even numbers. If they're north and south, they're all odd numbers.
okay. Yeah, and so that would match up with our Victor Airways there.
Yeah, exactly.
So good point. Great. Any other questions on this last page, actually, before we move on? Or comments? So you can see here, it's a 4.5 degree angle. That's how they determine the width. So it's 4 nautical miles wide on either side of the intended track. So 8 nautical miles total, but 4 nautical miles wide on either side of the intended track. So our Nav routes. So our Nav, it's not something that we're going to be using in this class. We want to stick to the ground-based navigation, but we're going to talk about what RNAV is and how they use it. So RNAV, once again, is talking about GPS. It's locations or waypoints that are, rather than using these ground-based navigational aids, they actually will tune into satellites, and you can see this blue star over here. Those are waypoints, GPS waypoints, and so they will navigate from GPS waypoint to GPS waypoint. And those routes that get them from each one of those waypoints is called, for the low charts, it's going to be called a T route, and for the high charts, it's going to be called a Q route. So both the US and Canada, oops, goodness, like I said, that mouse is really touchy. The US and Canada both use these RNAV routes. Oh, excuse me. For the US routes, they will be numbered, the Q routes will be numbered 1 through 99. And I think that may have changed just a little bit in the recent years. I'm not 100% sure. I need to check, but yeah, US routes are Q 1 through 99. And the aircraft has to be RNAV or RNP capable. So, in order to use these waypoints. Now, we have this new system. I guess it's not horribly new, but the US actually has these GPS waypoints throughout the entire country now, and it's on the grids of longitude and latitude. So we call these NRS waypoints, and you can actually use those to navigate now, even rather than using these Q or T routes. NRS allows us to basically really customize and break down a route to what we need to do. It's a lot more accurate. So rather than random waypoints, it is longitude and lines of longitude and latitude. So this random RNAV is just talking about, like I said before, these waypoints for RNAV are just kind of randomly placed throughout the United States. There's not a whole lot of rhyme or reason as to why the location was picked. As far as dispatchers are concerned, air traffic control is the one that has to approve them all, and they're the ones that determine, what to call these different waypoints. But yeah, as far as we're concerned, there's just not a whole lot of rhyme or reason as to why they locate them where they do. Excuse me. And RNAV provides more direct routes from location to location. They tend to provide more direct routes from location to location. And once again, radar, RNAV, RMP. To operate with RNAV or RMP, you have to have radar. So, yeah, that's kind of the gist of that RNAV section. Like I said before, it's not something we're going to use in this class. We will have, there is a question on the test that will, and we're going to talk just a little bit more about like satellite-based navigation. But as far as like looking at it on the IFR charts, that's pretty much the depth that we go into, because the system follows a lot along the lines as our jet routes and Victor routes. So don't worry too much. If you know how to look at a jet route or a Victor route, the RNAV routes are the exact same, just use satellite rather than ground-based navs. So preferred IFR routes. So there's city pairs that sometimes have preferred IFR routes. These can be found in what we call the AFD, or Airport Facility Directory. Some city pairs just, they want you to fly a certain route to reduce, like it says, it's the objective of the entire thing is to help with the planning, minimize route changes, and help air traffic control do their job better. The less they have to think about, the more time they have to actually watch what's going on their screen. So it just helps them be more efficient at their job. So certain city pairs, like I said, they'll actually have a planned route already in the system to help reduce the route change and air traffic control workloads. So, and as far as practical application goes of this, like we kind of talked about yesterday, the air traffic control coordinator, their job is to build these routes. And so if there's a preferred route, his job is to know that and to put that into the system. So it's really on him to put them into the systems, and they're there. It's just, if we can use them, that's what we're going to use. And typically, these preferred routes are the default routes. It's what is automatically going to populate on our flight plan unless we go in and change it. So
so
you were talking about air traffic coordinator. Is that designs these routes? Is that somebody is that a company position, or is that an FAA position?
That's a company position. So each company will have its own coordinator, and his job is to build company routes. So he actually works with air traffic control. He works with, the company, to whether it be Delta or United or whoever it is, to make sure that the route is okay with them and jives with them, and make sure that air traffic control will accept certain routes. That's all his job. Our job is just to, if that's the preferred route, making sure that the preferred route populated rather than some random route, you know. So all right, so these tower and route control routes, we call them tech routes. These are pretty much the only place that I can think of that you'll ever see these is in the Southern California area. And that's due to the amount of large airports right next to each other, the proximity of these airports. So it's really busy down there. There are other places that may have, you know, these en route control charts, but the first one that always comes to mind for me is this Southern California down here. Again, these are preferred routes, just like the IFR preferred routes. It's just with these tech routes, they want you to fly this route, just like the IFR preferred route, but then there's altitude restrictions as well that they'll put on these. So, you know, like Los Angeles down to San Diego, they don't want us flying higher than 11,000 feet and other things like that. So if we're flying from one of these airports in this area to another airport in that area, they publish routes once again in the AFD to tell us what route they prefer you to plan. Almost identical to the IFR preferred routes. So yeah, I mean, not really any different than those IFR preferred routes. And like I said before, the computer system will automatically try to plan those default routes every time we plan those flights. So our job's just to verify that we're planning the correct route. So in our routes, when we look at the way we know that we're planning the preferred routes is there's actually on the release, it'll tell us the route. We have specific route numbers that mean different things. When you're looking at like the default route, if the default route was planned automatically by the computer, it'll be a 001 or a Q1, or, you know, it'll be a number 1 route. Anything outside of that, you know, if you didn't mean to plan that, you want to go and make sure that it planned the correct route. But once again, that's practical application at your airline of choice, whatever it may be. So, yeah. Okay. So I'm going to have you guys watch a video now. This video is just going to help. It's just a good video to see kind of how airlines work. It teaches you some of the basics of airplanes, how they build them, how the airport works, things like that, how air traffic control works. It just kind of is a good overview. It was made by PBS in made by PBS also with BBC. They worked on it together. So, but it's just kind of a good video just to kind of get a grasp for airlines in general. So I'm going to post this here in the chat if you can watch it. There's 3 parts to it. we're just going to watch the first part tonight. It's called Depart. The name of the series is City in the Sky. But I will post this. You guys go on, watch that video, and then go ahead and take your dinner break. And we'll just jump back on at 7:10, 7:15. Does that sound good?
That works.
All right.
Sounds great.
So if you can't get it in the chat window, if you go to today's folder in the Google Drive, there's a file that has the link in that. So, but yeah, we'll see you guys in about an hour. We've been going through this and I didn't hit record. Crap. I apologize to anybody that is watching this post-class. Once again, this will all be the actual slideshow presentation will be on our Google Drive. So you can go back through these slides and there's, a couple slides that may have a little bit of clarification or notes to them. So I don't know if you guys will be able to see those or if that's just on my end. Anyways, minimum reception altitude. That's just talking about, like we said, the Rockies. Maybe there's a mountain or something of that nature that's going to be between two stations. So when we have an MRA, that's telling us that we have to be above a certain altitude in order to receive a signal for that VOR or for that station. So, and it's identified by a symbol. You'll see that as, let's look on these low charts. It's like an asterisk. There we go. Sometimes we'll see it there, so. MCA, minimum crossing altitude. So there's certain fixes where we have to cross at a certain altitude. Mostly talking about these low charts. The minimum altitude to cross a fix is just due to obstructions or obstacles. So once again, we'll see it identified with the symbol. Let me see if I can just find one really quick. Let's see. I'm not actually seeing it on this map right now. I thought I'd see it right here, but I believe that's one of the things that our video will go over tonight. Just to actually show you guys. You can also look on the legend and actually see those. Let's see if it shows it. Okay, here you go. This is the section that talks about the different minimum altitudes or maximum altitudes. So you can always refer back to this this legend to see the actual information. Yeah, so once again, identified by a symbol, you'll see it right there. This MCA here. So it's like a little flag. Oops. Okay, so once again, this chart here is just identifying the differences between the Jeppesen and NOAA, how we'll actually see it on the chart. You'll see this maximum en route altitude. The mochas are like a burgundy color. Your change in minimum en route altitude will be identified with two lighter, not bolded numbers with this gap here. And then when we talk about MCAs, they'll be identified like on the NOAA charts, they'll be identified like that. But on a Jeppesen chart, you'll actually see MCA. So and this is just going over, just kind of visualizing what we're talking about here. So MCA, the minimum clearance altitude, that just means that you're going to clear this obstacle. The MCA looks like that's interesting. Required clearance 2,000 feet. Am I thinking of something different? Well, there's the clarification. Required clearance 2,000 feet, not 1,000 feet. I must have been mixing up my method 1 and 2. But there you go. This just helps visualize that. You'll always see these at an intersection marking, and that just know that that's 6 miles to that highest obstacle. So yeah. These Arokas are off route obstacle clearance. You can see these just in these red boxes here. So in each block of longitude and latitude, you're going to see these light numbers in each box of longitude and latitude. What that's telling us is in that grid, in that box, the minimum obstacle clearance altitude, meaning that if you were to fly at this 12.1 altitude, you would clear all obstacles in that entire grid there. So 12.1, 12,100 feet. You would clear every obstacle in that box. 14.7 here, you see 15.1 here, 16.3 down here, 13.3 in this box here. Minimum off-route. So Aroka is what we call it on the NACO charts, or those NOAA On the Jeppesen charts, we'll call it a Mora, but it will actually look identical. They do it the same way. And there's what I'm getting confused here. 1,000 for non-mountainous terrain, 2,000 if it's in a mountainous terrain. So we know that this is a mountainous terrain, so this is giving us 2,000 foot obstacle clearance in this box. If we're out on the plains, we're only clearing obstacles by 1,000 feet. That's where the confusion was. And this just identifies where we designate mountainous terrain. So, just for safety's sake, we can just call the western U.S. basically from Denver west, mountainous terrain, and then all the way until we get into this this region between Pennsylvania, West Virginia, Virginia, North Carolina, Tennessee, Kentucky, and Alabama, and northern Georgia. That's pretty much everything else is just non-mountainous. And I think it's funny that they consider this mountainous when like their highest peak west of the Mississippi is what, like 5,200 feet or something ridiculous like that. So nothing we call mountains. Now this is just going through Jeppesen charts. And that's what the video is going to be. But yeah, it's basically the same exact information. It's just displayed slightly different. But we showed you the two differences between them. Let's cruise through this. Area charts. So this will take, it's kind of like a TAC chart, but area charts are just for like more dense, like there's just a lot of information that needs to be displayed going on. They'll put out an area chart for that area. Each one will be specialized or specified specifically for an area. Sorry. And it will be identified in the top right corner with just like every other Jeppesen chart is. So you also have these. Oh, go ahead.
You'd indicated that these charts are in the electronic flight bag. Is that?
Yeah. The electronic flight bag will have every chart that the pilot could ever need to operate. Area charts for dispatch sake, and these Class B airspace charts and the VFR corridor charts. For dispatch sake, we never get down to this level of detail. This is all something that is very pilot specific, and I don't know that I've seen a pilot in recent history use either one of these charts. So it's just way too detailed information for the type of flying we do. They may take a look at them in training, but that's the only time they'll really use these charts. But that's pretty much it. So are there any questions, comments, anything about all this information that I just dumped on you?
Hey, Garrett, you were talking about the ETOPS. I just put it in chat. But what's the longest flight that Skywest has?
It would be, I want to say it's the Minneapolis to San Francisco, which technically like I don't know where I just saved this to. Oh, downloads, okay. In the regional world, we're talking, if everybody doesn't know where Minneapolis is. So this is Minneapolis. San Francisco's down here. It's like a 4.5-hour flight. Technically, that shouldn't even be considered regional, but for some reason, Delta wanted us to fly that. So we do. I can't remember. It might be Alaska. But we also have one that's from Kansas City. Kansas City's somewhere down here to San Francisco as well. So technically, we shouldn't even really consider those regional, but because when we talk about regional, I don't know if anybody's really knows what, and it's something that you're going to hear a lot in aviation, the hub and spoke system. So what happens is you're going to have these designated airports throughout the United States. So this is Salt Lake City. This is San Francisco, LA. No, I'm sorry, that's not LA. This is San Francisco. I'm too high for San Francisco there. San Francisco's down here. San Francisco, LA, Seattle. What happens, the way the airlines work is your main airlines, you got Chicago O'Hare over here, Minneapolis here. They'll fly from, we call this a hub, to a hub. And then the regional airlines technically should be flying out to these smaller airports kind of in between the hubs. That's the hub and spoke system. So you can see that this kind of makes like an old wagon wheel. That's really the job of the regional airlines, is to get to those smaller outlying airports. The major airlines, their main focus is to get from these major hubs throughout the United States. They want to get to these major hubs and then use the regional airlines to kind of get everybody in between those different hubs. But Skywest is so efficient and so cheap to use that sometimes our major airlines are like, you can do that for so much less, so much more cost effective, and they'll give us one of those routes. So those flights are, let's just put it this way, they suck. Because of how long they're in the air, and typically you're weight restricted because of how long it is. You got to put so much fuel on there that you're bumping passengers to get fuel on board. But as for study guides, Crystal, when it comes to these nav charts, your study guide will be the legends. So what I would do is like aviation, or just do IFR high chart legend, and just pull up the official FAA information. And this is just not what I wanted it to do. Oh man, closed the wrong window. Here you go. Maybe. Unless it's another FAA crazy document. So this is the official FAA Aeronautical Chart guide. I guess I could put this in there for you guys to refer to. You can also just look at the pictures on that Google search. So if we go back here and just look at this images, this will give us the actual like legend that you would see if you had the actual paper charts. If you go into like any general aviation shop and buy one of these maps, just any one of them, they all have this legend attached to them. SkyVector doesn't have them easily available, but you can pull them up through this the charts here. If you just click on an area, you can zoom in here. It'll pull up the actual chart, and then you can zoom in here, and it will help you as you're going through and looking at these charts. You can actually refer to the legend here on the side, and it'll kind of help you identify the different things that you're seeing. But that's, as far as study guides, that's kind of what we have. We haven't put any Aircraft Dispatch Academy official study guides. The other thing I would study would be the PowerPoint that I'm going to attach right now. Where's my downloads? There it is. So both of those are now posted on the Google Drive. And just refer back to those. The other good reference is on YouTube. You can watch this class again. We've showed or invited. I believe Adam's invited everybody into this class. Into the channel. If you go into my channel and then go to playlists here, you can look at all of our videos in the April 2018 class if you want to refer back to this actual class, or you can go back to this August 2017 was when Adam taught. This is the last class that I taught. You can go back to either one of these and actually pull up, when we talked about specific things. And each one of them, well, I don't think he actually, there should be a description if you pull up the actual list here. Yeah, I don't.
The only thing that I'm seeing in the playlist is from this course.
Oh, really?
That's the link that he provided.
Can you go to channels, maybe. Nope. I'll have to talk to Adam, but it's really good to sometimes access. You clicked playlists, and it wasn't anything. There wasn't anything on his channel in playlists.
That's the link that he provided in one of his emails to me.
Okay. Oh yeah. Yeah. So on that link, just click playlists up here at the top, and it'll pull out to all of his different classes, all the classes that we've taught so far.
Oh,
as you can see, there's 44 videos there, 34 videos there.
Extremely helpful because my computer before was just a very expensive deck of cards.
Yeah. But you know, it's good to go back. I highly recommend listening to Adam's class videos, you know, as we go and cover subjects. If there's any confusion, sometimes it's really good to hear it from a different perspective and see how Adam teaches it, because we have different teaching styles. I mean, we try to cover all the same material in the same way, but sometimes he has a little bit more information, whereas I may have more information on a different subject. So I highly recommend, you know, using the YouTube channel as another study resource. So that being said, let me post these videos onto our little Scratch sheet here. So these two videos, YouTube videos, we'll go through, and you know, we've covered this information tonight, but like I said, it's good to hear it from another person. He breaks it down in another way. So becoming familiar with these charts is going to be really helpful when we get to our flight planning phase. And so please watch these just to kind of fill your time tonight. Like I said, I have to end class early. I've got a flight that I got to be on and got to get to the airport. So we'll resume class as normal tomorrow. And yeah, please come with any questions. We're going to kind of go through and talk a little bit more about these IFR charts, as well as the actual navigational facilities themselves, and help you get a better understanding of what those facilities actually do. So other than that, I'll turn you guys loose for the night.
Thanks, Karen.